My name is Brad Ack. I'm the executive director of an organization called Ocean Visions, which is a collaborative partnership of research and scientific institutions with practitioners and marine managers that looks for solutions to critical problems facing the ocean. And there's no problem more critical and dangerous than the impacts caused by too much carbon in the atmosphere. The 2 trillion tons of CO2 that we've put into the atmosphere since the beginning of the Industrial Revolution are heating and acidifying the ocean. These are the 2 largest threats to the health of the ocean over time. And so working on things like carbon dioxide removal is not only good for the climate and not only imperative for the climate, but also for the health of the ocean itself. So essentially, we're looking at whether the ocean can play a role in healing itself and healing the climate. Sean mentioned we have to have removal. The IPCC, scientific body for the UNFCCC, has said that every scenario to get to 1.5 degrees includes pretty significant amounts of removal, between 100 and 1,000 gigatons of carbon. A gigaton is 1 billion tons. So 100 billion tons to 1 trillion tons of carbon have to come back out of the atmosphere over the next 70 years to have any hope of getting to 1.5. How are we going to do it? The ocean holds about 50 times more carbon in the deep than what's in the atmosphere now. The ocean cycles most of the planet's free carbon. If we were to disappear tomorrow, the ocean would, over the next 100,000, 200,000 years, would recycle all this carbon pollution we've created. We don't have that kind of time, so we look at how can we accelerate, enhance, and mimic ocean pathways for carbon removal. There's a few big categories: giant kelp, macroalgae, rapid photosynthesizer, doesn't require land or fertilizer, captures carbon, many ways that you can store that carbon. Microalgae, also a rapid photosynthesizer that has unlimited potential to be able to move carbon, and already does move a massive amount of carbon in the system. To more engineered methods, alkalinity enhancement, adding alkalinity to ocean water to restore the pH that's been lowered by acidification, also has a knock-on effect of removing carbon. Direct ocean capture, which is essentially like direct air capture, but capturing carbon out of seawater itself. And then lastly, what everybody is aware of and knows about is blue carbon ecosystems. Those are the big 5 domains of ocean-based carbon removal. We're trying to accelerate research with partners like Cambridge on all 5 of those areas. And within each 5, there are many technology pathways. We need much greater urgency to this effort. Here we are at COP, and nobody in the negotiation room is talking about how countries are going to deliver that 100 to 1,000 gigatons of carbon. They're not talking about it. Even though it's in the science, it's not on the agenda. So we need to all collectively get it on the agenda. There's only 2 ways to solve this problem. We need both of them: reduce and remove. And we're falling far short on removal. If you want to learn more about some of these technology pathways, please visit oceanvisions.org/roadmaps, and you will find a wealth of information there about all of the different research efforts underway and how you can get involved and help. Thank you.